Hello, adventurer. It's good to see you. You have made it to the morning grind.
Welcome, welcome.
It's the live stream at the beginning of the Geekverse, where we talk about all types of topics in geekdom, gaming, and fantasy, with an emphasis on being constructive and creating the things that we want to exist in the world.
It's all on the grind, Sizemore. Can't be too fine, can't be too coarse.
That's exactly right. There are a lot of adventures to be had today. Dungeons to explore and monsters to slay, and who knows what a random encounter might send our way. That's why we have to prepare, so settle in now for the morning grind with your favorite beverage in hand.
Tea? Or maybe something a little stronger. I've got a few bottles of the old Wynyard left.
Whatever you want. Pull up a chair.
Dude.
If you're feeling fancy, how about a cappuccino? Or a frappuccino? Or how about an espresso?
Just tea, thank you.
Sounds good to me, Gandalf. Whatever you want. I'm just glad you're here.
Everyone is welcome. You can just watch if you want. You don't have to worship anything you don't want to worship.
Thank you, Mike. But be forewarned.
Sometimes we get really strange characters around here.
Wait, what's that you say? Why can't you come and be a part of the stream?
My wife would disown me.
Oh no, I bet she'll be fine with it. Come on in.
Am I scared for my safety? No.
What are we supposed to do?
Everybody do the secret handshake.
Secret cultist handshake.
Oh, now do wizards who love each other.
This, my friend, is a science.
I still don't have gifts, but it's fine.
It's all on the grind, son. Can't be too fine, can't be too coarse.
Dude, this would be a sick place to bring the band.
Indeed it would be, Dave. It really would. I'm seeing more people coming in. Welcome. Glad to have you here. Oh, look, here's someone new.
Is this the cultist meetup?
Yes it is.
Come to hang out? Please accept me. I have nothing else.
Okay, we accept you. Everyone's welcome here.
Brought some snacks.
Well, that makes things even better.
You want some coffee? I don't drink coffee. You sure?
It's cultist coffee.
What makes it cultist coffee?
I'm a cultist and I'm drinking it.
Oh. Then I'll have some.
What exactly is going on here?
I'm seeing more people coming in. Welcome. It's so great to have you. Oh, and look, here comes another stranger.
Can we help you?
Yes, fellow cultists. I could really use some food.
Oh yeah? Welcome. We have donuts.
Oh, it's me. I'm glad I'm here. I'm sure you have a few questions for me, though.
What's your name? Who do you work for? What god do you worship?
Great questions, Rob.
I'm Steve King, and I worship Nyarlathotep.
No, not really. I'm just Heath, and I won't be worshiping anything this morning. But I will be your host. Welcome to the office. We're going to have a great time. I've got my coffee ready, because now it's time for the morning grind.
If you could become a fish, that would be amazing. Then I could command you with my mental fish powers.
Good morning, everyone. How are you? I hope that you are doing well. Welcome to the office. Welcome to the morning grind. I had a tiring day of yard work yesterday and walked about 7.5 miles during yard work yesterday. It's hot down here. So I was tired all yesterday, and then I was going to work on getting my projects, some new projects ready to go, because I've got to get that ready to talk to somebody about on Monday. But then last night I got talking to a friend who I haven't spoken with in 10 years, and we ended up talking until 2 in the morning. And so that's late for me now. Connection is dodgy this morning. It's saying that everything is fine on my side. Let me check a couple of things, but it's saying that it's not saying that it's weak connection on my side. So we will see. So staying up until 2 in the morning is unusual for me now. So I'm feeling it at the moment. Good morning, Lynn. Good morning, James. Good morning, Sable Phoenix. Good morning. Good to see you. All right, let's see here. what's our purpose today? Our purpose here today is to go back to GURPS space. And this, I guess, this should be a world building Wednesday topic. And it probably would have made a really good one because this is going to get into basic world building. So basic world building, we've got basic world building and we've got advanced world building in here to get into. So this does seem like a world building Wednesday topic. We've got basic and advanced world building, and I think this is most of the rest of this book. Basic world building, advanced world building. Oh, alien life and alien minds. Oh, so there's also, okay, a future and alien civilization. So there's actually a lot here. So world building and then about aliens. So it makes sense. Alien creation. So there's also alien creation. Alien anatomy. Mobility size. Okay. I don't think that I want to get too caught up in the basic world building. Let's see what we've got here. Using worlds, because it might tell us kind of just general stuff that we already know. So I think I kind of want to go through with basic world building, if we can, rather quickly and see what it says. And then we do have different steps here. Step 2, step 3, step 4. It looks like we've got some sidebars. The sidebars are always fun. Distances and scales, why world types, toxicity rules, habitability for aliens, altering the colony population table. But then we get into advanced world building, generating star systems, generating world details, special cases. So it may be that we need to spend most of our time over here in advanced world building, but we will see. So let's just start at basic and see if it's too basic or if there's stuff in there that we need to consider. Could be great topics for conversations in here as well. This book has really spawned some great ones. Good morning, Rogue Thinker and Zero the Blade. Good morning. Yeah, we don't want to just morning. We don't want to be sending people, what do we do with morning stumps? If you just send the top of the morning to people, you end up with a bunch of morning stumps. And what do you do? So this one does cover aliens. So it says like building aliens, alien life and alien minds. Yeah. So alien creation 3. So world and alien building. Alien anatomy, for instance. So I guess, how long is this book? Because we were talking about, this book is 240 pages. And just out of curiosity, so world building and alien building and star system building and stuff is very important. The Starships book itself is 69 pages. So that would have been a 300-page book if they had tried to put all of those together. I'm trying to come up with a reason why they decided to not have the spaceship building rules. Well, okay, so the basic set, the GURPS basic set characters is 336 pages long. So I guess if they had decided to put the spaceship rules in here, it would have ended up being just as long as the main rule book. So maybe they didn't want to do that as a supplementary book. Oh, what do you want to bet? It's got to be. Let's breathe and sip this morning. Seems like, here we go. Basic world building. All right, let's breathe and sip this morning. I got a Cultist coffee mug out this morning. Even though I've got Mountain Dew Zero. All right, let's breathe. 2 deep breaths. Inhale, complete exhale, and then take a sip of your favorite beverage this morning. And then say, ah. Here we go. Ah, there we go. Tomocrat says, I'm thinking page size. I've noticed that some newer books go nuts with pages since PDF doesn't matter. And this one was designed for print. This was 2006, we said. So this was a book that was designed for printing. Yeah, you can go crazy, but you still have to write all the material and lay it out. It doesn't matter. Your page count doesn't matter when you're doing PDF as far as printing concerns go, but it does matter as far as getting the book written and laid out. Chapter 4, basic world building. All right, so what's in here? Dramatic roles. The most important decision the GM must make for the world is the role in the campaign. What type of story is it going to be told? What kind of story is going to be told with this world as a backdrop? So they offer world categories like Paradise World, Hostile World, Hell World. A Hell World is even harsher than the Hostile World. Humans can't survive there without elaborate technological measures. Changing World, Doomed World. One subset of the Changing World is the Doomed World, the planet that's soon to be destroyed or at least rendered incapable of supporting life. Crossroads. A crossroads world is special because everyone comes to visit it. It may be a major jump of jump lines. It may be an economically dominant world that trades across half the continent. It may be an imperial capital or simply an attractive world that everyone plans vacation here. An exotic world is one of the two. The exotic world is one that is actually unique in known space. Some feature or whole environment is a result of strange events that haven't happened anywhere else. Exploited world, forbidden world, like Genesis, I guess. A common trope in sci-fi is the forbidden world, the planet that's cut off from foreign visitors. Home-based world, primitive world, invisible or historical world. Let's see what it says. Common origins, common causes. When designing his campaign framework, the GM may consider requiring that all of the PC adventurers come from the same world. This works best when the world in question has been developed in considerable detail, supporting a broad variety of character types. This requirement certainly constrains the character development, but has several advantages. It makes it easy to build characters with shared plot hooks. Characters that grew up together or have already worked together in the past will be easy to bring into the same adventure. It also tends to give adventurers common motivation. If their shared home is in danger of internal conflict or an external threat, it becomes easy to involve all of them in epic adventures. Also an add-on for selling for the smaller book, yeah. And it may be also the Starship rules were complex, and so getting it together too, there may have been a time issue too. Tomocrat says, I wonder if they have the false utopia world like the ones they have in Star Trek. Oh, that would be interesting too. Paradise worlds, let's see. Paradise worlds may seem like an unlikely place for adventure. If life is easy for everyone, there shouldn't be much room for serious conflict. The GM might use a paradise world to make a point about the idea of paradise. Perhaps the world has a hidden flaw, a terrible price that inhabitants pay for their easy life. Paradise worlds also make good targets from star-spanning threat of the kind that requires heroic PCs for intervention. So it does kind of talk about that there. But yes, that's a good one. They should have probably played that one up more. The false utopia world. Puzzle world. Naturally, a puzzle world is one where local conditions present a mystery to visitors. Naturally, almost every alien world is a puzzle world in that sense, but in some cases, the mystery is critically important. Synthetic world, unique resource world, depth of detail. Sounds like we could pass over that very quickly. But depth of detail is, aside from considering the role a given world is to play, the designer should think about how much detail he really needs. A world that's going to dominate the campaign should probably be designed in greater detail than the one the PCs will visit once on their way to a more important place. Sounds like it's going to give us plenty of detail and advanced world building. Grand stage, any planet is a world, the product of billions of years of history, operating on landscapes hundreds or thousands of miles in extent. Even an uninhabited world can provide almost unlimited puzzles to solve and locations to explore. An inhabited world, its population in the millions or billions, will have at least as much variety and depth as present-day Earth. A world could be considered a grand stage for dozens of adventures developing in great detail used over and over. That's like Forgotten Realms or worlds like that. Repeated visits soundstage. A world that's only going to be visited once, even as the focus of an adventure, can often be developed in very low detail. This is called the soundstage level of development. Depth of realism. Another consideration in world design is how much realism the GM wants to inject into a setting. Realism in setting design isn't an absolute virtue. It's what's necessary. What's necessary is plausible. What's necessary is plausibility. The audience of the story, film, or role-playing session wants to be able to suspend disbelief and enjoy immersion in the new flow of events. Each audience will have its own standard, and every subgenre of science fiction has its own requirements. A world design that fits perfectly into space operatic universe might be nonsensical in a high realism, hard sci-fi setting, or vice versa. Very few sci-fi authors ignore realism in their world designs, but some pay more attention to it than others. A good author or GM will be concerned with characters and story. Some authors, notably Paul Anderson and Hal Clement, have made a fine art of using rigorously plausible and distinctive settings to drive their stories, but other approaches are just as effective. In general, as with other discussions of real-world science and technology in this book, the world design rules are intended as tools for you to use when producing the space setting you want. Use, rewrite, or ignore them to taste. And we have a quote here from John Milton, Paradise Lost. A broad and ample road whose dust is gold, and pavement stars as stars to thee appear, seen in the galaxy that Milky Way, which nightly a circling zone thou seest, powdered with stars. Powdered with stars. So we got, mapping the galaxy. Distances and scales. How do we draw a map of the galaxy? How many worlds? Most space-oriented games will use just one star system, perhaps our own solar system, perhaps others that have been colonized by humans. Drawing the map, though. The type of map to draw depends on the scope of the campaign, and especially on the type of interstellar travel that is available in your universe. All of this, I'm sure, also is one of those things. What's the most I can possibly do to run this campaign? We talk about what's the least you can do. You're talking about prep in advance. I'm trying to run this campaign. This is definitely the macro to the minor, the macro level down, which may not really be necessary if you're just trying to design a campaign and get players playing. But if starships will move by jump lines or a similar system, space can be mapped by drawing the jump lines. The actual distance between two stars in space may be irrelevant, and everything else that's on the jump line can be ignored. If jump line travel is instantaneous, only the connections need to be drawn, and the map can be quite abstract. Otherwise, the amount of time it takes to traverse each connection might be indicated somehow. A jump line map may also include information on how long it takes for a ship to travel from each point to a nearby world or other place of interest. It becomes like a subway map, right? The map of the universe is like a subway map. Does it give an example of that? I guess it does not. If faster than light travel depends on normal space distance between stars, then a scale map of the campaign area will be needed. If starships move through normal space, then possible hazards like nebula should be mapped. If starships move through hyperspace, then normal space phenomenon between stars can probably be ignored. Of course, if there are terrain features in hyperspace that might slow down travel or make it more dangerous, those need to be mapped. Mapping space is sometimes inconvenient because paper maps are flat, but space isn't. The GM may choose to ignore this, placing all of his star systems on the same plane. That's more realistic. It's more realistic to use a three-dimensional grid system. Is it going to give me an example of how to do that? That's what I wanted to know. Like, are we supposed to be mapping this in 3 dimensions? The map surface then represents a convenient plane using either the plane of the galactic disk or a plane defined by Earth's equator. A star above the reference plane will be mapped with a plus sign, followed by its distance above the plane in parsecs. A star below the plane will be mapped using a minus. Okay, I guess that works. As long as you don't have stars and things that are directly on top of one another. Thus, if Lestrad's star lies 4 parsecs below the reference plane, it would be noted on the map with a -4. To find the distance between 2 stars when using 3-dimensional coordinates, apply the Pythagorean formula. D equals the square root of x squared plus y squared plus z squared. It's been a while since I've thought about that. So D is the total distance between the 2 stars in parsecs, where x, y, and z are the distances between them along each of the 3 axes. So the total distance between them in parsecs is the square root of the summation of the squares of the distances between them along each of the 3 axes. So, for instance, distances and scales. Astronomical distances aren't conveniently measured in miles, although this book will refer to miles in some cases. It normally uses several different units to measure distances on different scales. The Earth diameter will sometimes be used in this book to measure the size of worlds and distances from worlds to their satellites. Astronomers don't usually use this unit, but it will make some of the world-building calculations more convenient. Earth's diameter at the equator is about 7,930 miles. An astronomical unit, AU, is the standard unit used in this book to measure interplanetary distances. 1 AU is equal to the average distance between the Earth and the Sun, about 11,730 Earth diameters, or 93 million miles. The light year is equal to the distance light travels in a vacuum of space in the course of 1 year. It's equal to about 63,000 AU, or 5.9 trillion miles. This book doesn't use the light year often, but it is a common measure in distance in astronomy and in science fiction. A parsec is the standard unit used in this book to measure interstellar distances. Astronomers measure the distance to a nearby star by observing its parallax, its apparent angle of motion across a baseline of 1 AU. If the parallax is equal to or exactly 1 second of arc, then the star is 1 parsec away. 1 parsec is equal to 3.26 light years, or about 206,000 AU. So how do we get parsecs? So we're measuring the distance to a nearby star by observing its parallax, an apparent angle of motion across a baseline of 1 AU. If the parallax is equal to exactly 1 second of arc, then the star is 1 parsec away. I don't think I ever knew that's how you derived what a parsec is. We have that terrible line by Han Solo where he talks about how fast the Millennium Falcon is, and he gives it in terms of, did the Kessel run a certain number of parsecs? Whereas actually, that I did know for a long time, that's a unit of distance. I need an example though of that. Probably find that on YouTube. Exactly how the distance of a parsec is calculated. Good morning, Stray. Good morning. Yeah, I know. I was thinking about that too. It's over 82 AUs in diameter. That's talking about the V'ger cloud. Lynn says it uses the small angle formula. Massive cloud. Okay, so astronomical features. Campaign maps can include include a variety of different scales. So galaxies are the building block of the visible universe. Galaxies are much more closely packed relative to their scale than the stars within a single galaxy. Galaxies often interact. The largest one seems to have formed by absorbing their smallest neighbors, a process that continues to this day. Meanwhile, even full-size galaxies sometimes pass close to or directly through each other, distorting their shapes and affecting the other's evolution. Galaxies normally come in 3 different categories: elliptical, spiral, and irregular. Each of these has significantly different properties. Elliptical galaxies have the shape more or less of an elongated sphere. A few elliptical galaxies, the lenticular galaxies, show the beginnings of a central disk and may represent a transition type between elliptical and spiral. Elliptical galaxies vary tremendously in size. Small dwarf ellipticals are only a few hundred parsecs across and may contain only a few million stars. Only a few million stars for your adventuring this weekend. The large elliptical galaxies are hundreds of thousands of parsecs across and contain many trillions of stars. This huge elliptical galaxies, hundreds of times as large as our own galaxy, are among the largest objects in the universe. Elliptical galaxies have an undifferentiated shape because they don't have a strong preferred direction of rotation. Component stars may orbit the sun's center of mass in a wide variety of different speeds. Many elliptical galaxies are relatively barren places with little to no new star formation underway, whereas spiral galaxies have a strong flattened shape with much of their visible matter restricted to a galactic disk. Spiral galaxies usually have a very obvious structure, with most of the visible stars arranged in a set of spiral arms. Many galaxies are much less variable in size than elliptical galaxies. Most spiral galaxies are between 5,000 and 50,000 parsecs across and have between 1 billion and 1 trillion stars. All right, well, now we can have an adventure, right? With 1 billion or 1 trillion stars to explore. And Eve Online, Stray says, I have a ship that warps at 13.4 AU a second. Sable Phoenix says, the Kessel Run is full of black holes and junk and is constantly shifting, so Han Solo was saying that he's a real hotshot pilot. Yeah, that was, yeah, so now they say, well, now, wait a minute. So what he said that, so what did he mean by that? Yeah, they turned it into some type of, what Sable Phoenix is talking about here. And like the quality of the Falcon's navigational computer to make the run in a certain distance. Lynn says, I find parsecs are the best unit for star maps because 1 parsec is about as close as any 2 star systems come to each other. Oh, interesting. How far away how far is Zeta Reticula from Earth? $39.7. 39.17. We said the parsec is 3.26. But that's basically 12 parsecs away. What's the closest star? How far is the closest star that's not the Earth? Not closest star that's not the Earth. Closest star that's not the sun. Closest star to Earth, not the sun. Proxima Centauri is still in light. Give it to me in light years or in parsecs. Can I just get that directly? So Proxima Centauri is 1.3 parsecs away. 4.24 light years. Tomocrat says, I still think that parsec thing was a writing screw up. I don't care what Lucas says. I think it was a writing screw up too. I think it was a writing screw up, and now it's just been what do you call it? Retro, whatever. There's some word for writing when you do that. When you go back and like try to come up with an explanation post hoc to cover over a mistake. I think it was just a writing mistake as well. Nearest star is Alpha Centauri, about 1.4 parsecs. Proxima Centauri, which is a hair closer, right? A retcon. Yeah, it got retconned. Yeah. That's the word I was looking for. Let's see here. A spiral galaxy structure forms because it rotates strongly in a specific direction. Most of the stars in the disk revolve in the same direction in more or less circular orbits around the galaxy's center of mass. Retroactive continuity. Post hoc ergo propter hoc. It's been a while since I've heard that one. Bigger than galaxies. Galaxies are not distributed randomly through the universe. Almost all galaxies are found in groups or clusters. A group of galaxies is smaller, usually with no more than 30 member galaxies, about 0.2 to 1.5 million parsecs across. A cluster is usually larger, containing up to several hundred galaxies in space of about 1.5 to 3 million parsecs across. Groups and clusters of galaxies are themselves organized into superclusters. On the largest scale, the universe is full of galactic associations, arranged in clumps and sheets as if on the surface of great bubbles of empty space. These voids are almost empty of matter and usually about 1 to 400 million parsecs across. No, I didn't know that. So the galaxies are arranged in clumps and sheets as if on the surface of great bubbles in empty space. The voids are almost empty of matter. So they're great voids between galactic clumps. These voids appear to be distributed fairly evenly through the universe. Current cosmological theory has yet to explain why the universe is arranged like this, at least in 2006. The galactic disk establishes a three-dimensional system of coordinates that will be used in this book for interstellar mapping. Lynn says, I've only encountered a handful of science fiction stories that involve more than one galaxy. I was actually thinking about that as I was reading through this just a moment ago. I was like, all right, how many stories? Because if you're doing wormholes and jumping like that, well, then why not have more than one galaxy? I mean, it's not like it's necessary, right? That's probably one reason why it's just not necessary to have, you've got plenty of planets and plenty of space and to explore and plenty of things to do and places to go within a single galaxies. So why have more? With jump drives or wormholes, you certainly could. But Star Trek and Star Wars are both single galaxy. Dune is one galaxy, right? I would not be able to come up with, off the top of my head, a multi-galactic. Yeah, even Star Wars uses only one galaxy. Yeah, I couldn't come up off the top of my head with one that is multi-galactic. Intergalactic. The voids are hard to use throughs in, I think, nothing to push off of. Oh, the Lensman. So Sable Phoenix says, then that's not one that I know. The Lensman series goes multi-galactic. So let's talk about mapping then. Three-dimensional systems of directions that will be used in this book. One direction perpendicular to the plane of the disk is called galactic north and points above the plane. The opposite direction is galactic south and points below the plane. The line on the plane of the disk passing through the galactic core defines the direction of coreward. A line on the plane of the disk passing through the galactic core defines the directions of coreward, toward the core, and rimward, away from the core. Finally, with the disk plane but perpendicular to the coreward and rimward line, another line defines the direction of spinward in the direction of galactic rotation and trailing opposite the direction of rotation. So we've got galactic north, galactic south, coreward, a line on the plane of the disk passing through the galactic core defines the direction of coreward toward the core, and rimward away from the core. Finally, within the disk plane, it's but perpendicular to the core. Do we have an illustration of this? Galactic. So we define spinward and trailing. Let's see here. Galactic coordinates. Let's see. Is Wikipedia going to come to our rescue here with an illustration? Let's find out. Well, actually, there's a lot here. Let me look up images here. I see stuff about this is I see some of this is about actually solar system coordinates. Well, here's somebody who just has galactic North Pole, galactic South Pole, and then is using galactic longitude and galactic latitude. Well, I understand that. Like that, okay. So some people are using latitude and longitude. Oh, Stargate, you go to multiple galaxies. It's been a long time since I have watched Stargate. See something like a Stargate. And some of David Brin's stories visit more than one galaxy. Thank you for the link to the store and the coffee. If you do want one of the coffee mugs, I have a few left. I'm going to put them. I've got another project coming up where I've got to put the last of these mugs as well. So if you like the cultist coffee mugs, that's the spinoff of the Starbucks logo, I have a very few of them left. They're over there on the Ravenkeep online store, ravenkeep.net. So much of the disk's matter falls in the spiral arms. Long structures that have looked down on the disk from the galactic north curve counterclockwise as they move from the core out to the fringes. The spiral arms are not smooth curves forming a regular pattern. The densest part of these arms fall into a series of short, discontinuous arcs. Excuse me. Maybe I'll be able to speak here. Maybe. All right, that's better now. Oh. The galactic disk is embedded in the galactic halo, a spherical structure that takes up most of the galaxy's volume. The halo contains very little gas or dust, and only a few % of the galaxy's stars. Oh no, I got the hiccups. The stars of the halo are old and dim, many of them orbiting the core at wide angles to the plane of the disk. Such stars punch through the disk twice in the course of each long orbit. Okay, going out to one of those stars, that sounds like a good place to have something weird you got to go out to one of the halo stars. Strangely, the halo appears to contain the majority of the galaxy's mass, which must be in the form of undetectable dark matter. Oh, that's interesting too. The halo is densest toward the center of the galaxy, where it shades into the galactic core. This is a flattened bulge about 1,800 parsecs thick. The core is somewhat elongated, making our galaxy a moderate example of barred spiral. The best current model of the galactic bar makes it about 1,800 parsecs wide and about 5,400 parsecs long, with its long axis pointed in the general direction of Earth. The galactic core is composed of older stars with fewer clusters of bright young ones. It's extremely dense in the inner regions with many stars per cubic parsec. So so you have many stars per cubic parsec actually in the core, so that you can have them be denser than the 1 parsec in the core. Current observations indicate the Earth is about 30 parsecs above the plane of the galactic disk, about 7,700 parsecs from the center of the galaxy. Sol is located in what astronomers call the local arm, one of the galaxy's 2 major spiral arms. This arm is about 1,800 parsecs across and winds halfway around the galaxy from one core to the fringe. The center line of the local arm passes about 100 parsecs rimward of Sol. The arm passes about 100 parsecs rimward of Sol. So Earth is fairly close to the heart of the arm. This is no more than coincidence. Sol and Earth are simply passing through the region of on their own orbit around the galactic core. Lynn says it's easier to go to a halo star that's currently passing through the disk. Yeah, right. So they do sometimes pass. It said it passes through twice, right? Such stars punch through the disk twice in the course of a long orbit, in their long orbit. But yeah, I think it'd be more fun to go out to one that's not. Yeah, I hope so. Hey, Neutromancer. Yeah, the core is a special case, very densely packed. You want to use centiparsecs for your scale there. So, all right, galactic features. We do have globular clusters, which are dense stars. They usually are 50 to 100 parsecs in diameter and contain up to hundreds or thousands of stars. Globular clusters are very old, 10 billions or more. They formed even before the galactic disk was well established. Most of them remain in the galactic halo, where they found very wide orbits around the galactic core. Stars in the globular cluster are very unlikely to have stable life-bearing planets. The clusters are rare. The nearest one to Earth is about 2,000 parsecs away. So we got open clusters of stars, associations or groups of stars that have dispersed from their original open clusters but are still located close together. Molecular clouds or dark nebulae are clouds of interstellar hydrogen interspersed with heavier elements and dust grains. They are much denser than the normal interstellar medium. When they are parsecs thick, they can obscure most all of the light from the stars behind them, giving the appearance of dark holes in the sky. On the other hand, when they are illuminated by bright nearby stars, they can shine in vast billows and trajectories by the reflected light. Okay, so what is our frequency of worlds? There are about 400 billion. Are we going to get into the Drake equation here? Maybe. There are about 400 billion stars in our galaxy, and it seems likely that at least 1/3 of them, about 130 billion stars, have planets. How many of those are home to intelligent life? Anyone's guess? All of our estimates are based off unproven assumptions. The situation may change in the coming years as better space telescopes continue to give us more information about other solar systems. For now, even a GM interested in realism is free to make useful worlds as common as he likes. It's possible that interstellar civilizations will be in the habit of colonizing and using every star system, no matter how inhospitable or barren. Unless this is the case, many stars simply won't be worth bothering with. Even under a generous estimate, pleasant Earth-like worlds are outnumbered by dozens to one by barren balls of rock and ice. alien and many science fiction universes are busy, chatty places. They're full of multiple alien species, all about the same level of development, permitting them to talk to and shoot at each other in dramatic and interesting ways. And ultimately, the real universe doesn't appear to be so densely populated. Many scientists agree that intelligent, technologically advanced life must be a rare phenomenon in the universe. There's no clear-cut evidence for past visits of alien intelligence to Earth. Astronomers have never detected an unambiguous signal from another world. We see no sign of interstellar scale engineering projects such as might be mounted by advanced civilizations. The universe appears to be a quiet place. The dearth of evidence for aliens places a limit on the frequency in which are likely to exist in our universe. If a community of technological advanced alien species existed within 100 light years of Earth, we would have detected it by now. This suggests that such species don't appear more often than about once in 10,000 star systems. I wonder if this is some of our latest info here. Dark matter is a pretty little fiction. What makes more sense, that most of the universe is made up of matter that somehow doesn't interact with any electromagnetic frequency, or that our standard model of cosmology is just wrong? The Webb telescope is already scuppering a ton of our hypotheses of how the universe works, and dark matter, dark energy makes even less sense than just admitting we haven't the faintest idea what's going on out there. The Neutromancer says, I love GURPS because of all the educational stuff that barely has anything to do with the game mechanics. So well, yeah, this is very much, like I said, in the vein of what's the most you can do. Well, okay, you want to run a space campaign or a space game? All right, let's run a space game. First, let's go ahead and get you up to speed on all of the latest that has to do with classifications of science fiction, categories of star systems, and all of that. That way you can make some intelligent choices regarding all of that for your particular game, and then we'll get you into the rules. Let's see. Worlds bearing complex life. If intelligence seems rare, life is probably very common. Although alien life is yet to be unambiguously discovered, astronomers have found its chemical building blocks in surprising places, in the heart of meteorites and the atmospheres of other planets, even in the vast molecular clouds found in deep interstellar space. On Earth, primitive life seems to have begun almost as soon as it could. Astronomers have defined a set of conditions for stars that are likely to have Earth-like worlds, home to complex living organisms. A star must be stable and long-lived. It must not be too bright, as the brightest stars rarely have planets. It must not be so dim that its planets are too cold. It must not be too old, as the oldest stars are metal poor and may not have planets. It may not be too young, as it appears to take billions of years for complex life to evolve. It must not be tied to a partner star whose gravitational influence could make an Earth-like world's orbit unstable. Given all these conditions, it seems unlikely that more than 10% of all star systems will shelter complex life. A more realistic estimate might be place the number in 3 to 5%. But given the above, 90% or more of all star systems will be barren, containing no complex life, and probably little else to set them apart from each other. But they still may be worth visiting. We could think of all kinds of reasons from story perspective to get somebody out to one of these worlds. So, okay, so here is choosing. Let's look at our choosing a preferred scale. We've been talking about scale of adventure here. Neutromancer says, if you wish to make an RPG space supplement from scratch, you must first invent the universe. Yes. And this didn't talk about GURPS universe creation. We hadn't gotten to that. Stray says, Traveler has an online star map. It's massive. That might be fun to look at. So the choice of scale for an interstellar setting is one of the most fundamental decisions a GM must make. Is the setting going to be vast, covering a significant part of the whole galaxy, or is it going to be a tiny chip of explored space, including no more than a few star systems? This choice affects not only the number of worlds that fall into the campaign map, but also the selection of faster-than-light and other technology assumptions. See chapters 1 and 2, which we have. The GM can get an idea of his preferred scale by deciding how many star systems play host to intelligent life and how many of them gave rise to complex, unintelligent life. Then he can decide how many of each kind of worlds he wants to have in his setting. Along with an assumption about the density of stars in space, this can give the volume of the campaign map. In the neighborhood of Sol, there's one star system for every 12.5 cubic parsecs. Different densities can be assumed in other regions of the galaxy. Once the scale is selected, the GM can consider the typical speed of interstellar travel. How long can an adventurer expect to travel from one world to the next, or from the center of the campaign map to the edges? Unless the adventurers are likely to take place on board a ship, time travel between worlds should probably not be more than a few weeks. If there's regular contact between the core and the fringes of the campaign setting, the longest trip shouldn't take more than a year or so, unless years' voyages are typical for the setting, as in many slower-than-light-based universes. Playing with shapes. When deciding on the scale of an interstellar campaign, the GM can make use of a couple simple mathematical formula. Given a sphere of volume V, then the radius of the sphere, the distance from its center to its surface, is about 0.62 times the cube root of V. Given a cube of volume V, then the length of each face of the cube is exactly the cube root of V. The length of each face of the cube is exactly the cube root of V. Given a region of space of volume V and some number of points n distributed random inside the region, then the average distance between two neighboring points is therefore about 1.12 times the cube root of V divided by n. This assumes that the region of space has a simple shape, but it doesn't have to be a sphere. A cube volume that can be more conveniently drawn on a standard piece of graph paper will do. The first formula is useful when deciding how big the space for a campaign map. The first formula is useful for deciding how big the space for a campaign map covers will need to be, assuming the stars are evenly distributed within the mapped region. The second is useful for determining the average travel time between two neighboring worlds on the map. For example, suppose the GM assumes that intelligent life, alien life, is found once in about 10,000 star systems, and he wants to have six starfaring species in his campaign. This suggests about 60,000 star systems within the space covered by the campaign map. At 1 star per 12.5 cubic parsecs, the map will need to cover 60,000 times 12.5, 750,000 cubic parsecs. The GM decides that he will use a spherical shape for his campaign setting. Applying the formula for the sphere's radius, he finds the campaign map will need to cover a sphere with a radius of about 0.62 times the cube root of 7,500 is equal to 56.3 parsecs. A map covering a sphere with a radius of about 60 parsecs should be enough. The GM then decides the sphere will include about 200 interesting worlds, most of which won't be placed until he needs them. How far will each world be from its neighbors? Applying the formula for average distance, the GM computes a distance of 1.12 times the cube root of 750,000 divided by 20 is equal to 17.4 parsecs. This distance should be typical for voyages from one world to the next in the course of a campaign. If a voyage is expected to take about a week, then the typical faster-than-light speed for a starship needs to be about 17.4 divided by 7, 2.5 parsecs per day. At that speed, a voyage from the center of the campaign map to its edge will take 60 divided by 2.5 equals 24 days. So calibrate what type of faster-than-light travel is going to be going. So that's 2.5 parsecs a day. Sounds like a job for hyperspace. Meanwhile, the 60,000 stars on the map will include several thousand with life-bearing worlds and tens of thousands of barren worlds. Clearly, the GM won't need every one of these star systems, which is a good thing because he can't even begin to draw every one on his map. Lynn says, I think if you want to run a Golden Age campaign, it's fine to go with the fiction that every star system has its own intelligent race. Well, I was thinking about that too. I think that's probably fine too. This is very interesting, this formula that they give here. I like it, but man, yes, this is definitely having a lot of planets out there. But especially for Golden Age kinds of sci-fi games, going to a new solar system probably takes you to another alien race. That would seem fine too. Neutromancer says, I would probably start with a blank map, probably with some POIs, so points of interest, and fill as we play. I like the idea back when every nook and cranny of every RPG campaign wasn't mapped. I think I would start with that too. That goes back to what's the least you can do in order to get this started and get this playing. World design sequence. So what is our, world design sequence? Okay, let's just go to the steps here. Step 1, concept. To begin the process of world design, you should come up with a concept for the world. Make a note of the dramatic role that it's going to be playing. To demonstrate the world-building rules, we will use them to generate a world and star system for a GURPS space campaign. After reviewing the options in Chapter 1, the GM has decided to build a high-powered space opera universe. He decides that humans have a faster-than-light travel for thousands of years and have spread throughout a large region of the galaxy. There are lots of alien races, some of them derived from humanity in the way of genetic engineering. The most important interstellar society is the setting as an empire dominated by a hereditary aristocracy. In the example, the GM wishes to design a frontier planet distant from any major worlds and cut off from the main trade routes. After thinking about a concept, he decides their world, named Haven, will be an invisible world, page 65, settled by various dissidents and renegades who are hiding from imperial authority. He further decides the Haven isn't on the imperial maps because its star system is in the midst of a dense star cluster that's difficult for faster-than-light navigators to negotiate. He has no preferences about Haven's surface environment and will use the random tables and his own inspiration to develop that. Step 2, world type. In this step, the world's type is determined. The world's type is overall class of worlds. In particular, a world's type depends on what volatiles are available on the world's surface. Volatiles are chemical compounds with low melting and boiling point that makes up the bulk of the planet's atmosphere and hydrogen, if any. And hydrosphere, if any. Hydrogen, nitrogen, oxygen, water vapor, carbon dioxide, and a number of other familiar compounds are all volatiles. A world's type is normally described in 2 terms. One gives the general size of the world, tiny, small, standard, or large. Each of these expand into 2 subtypes, usually tied to local temperature, which further define the conditions of the world's surface. Good morning, George. I know, front-loading your prep work, it sucks, especially when it's not ever probably all used. So tiny worlds are so small that it cannot retain a significant atmosphere, no matter how far from its primary star it's located. The following tiny worlds types are incredible: tiny ice, tiny rock, tiny sulfur. This world type represents certain gas giant moons that experience a tremendous amount of volcanic activity. Tiny sulfur worlds undergo a great deal of tidal flexing in the course of their orbit due to gravitational influences of the gas giant and its other large moons. So Io surrounding Jupiter is of this type. So that's tiny ice. Jupiter's moons Callisto, and Europa. Tiny rock include Mercury and Earth's moon. World types and skills. The world types given in this book map to the planet types described under planet types in B180. There's planet types in basic, page 180. What is it telling me about planet types here? Oh, planet types. Yeah. So this says that in GURPS, biology, geology, and meteorology, those are skills in GURPS here, require you to specialize by planet type, of course, because this is GURPS, as does the physical specialty of geography. If you do not specify a planet type, your native planet type is assumed. So if the campaign will never leave your homeworld, save space and just write geology, biology, etc. GURPS sorts planets into 6 broad categories for these purposes. Earth-like, essentially all habitable worlds. Gas giants, these are Jupiter-Uranus types. Hostile terrestrial, Venus types. Ice dwarfs, comets and other small moons composed almost entirely of snow or ice. Ice worlds, rock worlds covered by a frozen ocean, and rock worlds, most moons, asteroids, etc. Unless otherwise specified, all planet type specialties for a given skill default to one another at -4. Traveler Book 6 Scouts has a star system generation set of tables that's pretty good and follows current astronomical nomenclature. Traveler Book, I'm going to have to get into Traveler. That's another one that comes up a lot. Science fiction adventure in the far future. Let's see. So we were looking at this. We got caught up. Okay, there are planet types that were defined in the basic set. This affects which skill specialties scientist characters will need on each world. Earth-like, standard, garden. Oh, so now we have a bit more, divide these world types a bit more into different types. So Earth-like now becomes standard garden, standard ocean, large garden, and large ocean worlds. Gas giants, gas giant worlds. Hostile terrestrial. Standard ammonia, standard greenhouse, large ammonia, and large greenhouse worlds. Ice dwarves are tiny ice worlds. Ice worlds are small Hadean worlds. Small ice, standard Hadean, standard ice, large ice. Rock worlds include asteroid belt, tiny rock, tiny sulfur, small rock, standard. This is a word I don't think I've ever pronounced. Chthonian and large Chthonian worlds. So small worlds, standard worlds. A standard world is large enough to retain water vapor in its atmosphere, which is normally quite extensive. They have liquid water oceans, which others have vast deposits of water ice, although some standard worlds have of this type are extremely hostile. Others are among the most likely homes for complex life and other intelligences. Tomocrat says more math. It's not a subdivision. It's saying how their own classification matches the basic on space. Seems to separate things like size, atmosphere, hydrosphere, rather than having general Earth-like as type. Oh. So it's not. So well, we have different types. Yeah, okay. Yeah, I didn't go back to the first sentence. So yeah, the first sentence was the world types given in this book map to the planet types described in B180 as follows. Gotcha. Yeah, was the first sentence there. I got distracted by going to page 180. So why world types? Why are we doing this? Planets are complex and diverse things. Consider the case of Earth and Venus in our own solar system. The two planets have close to the same mass, have very similar composition, exist as very close neighbors within the solar system, and presumably began their histories with similar budget of volatiles. Yet today, they are vastly different surface environments. The Earth is cool, wet, and pleasant. Venus is furnace hot and utterly dry hell. Designing all the factors that determine how a world will evolve is a matter for an advanced university research team. And in fact, there are many facets of planetary development that are still unclear to human science. If we want to design a setting for a novel or role-playing game, we must simplify. Fortunately, we have good reason to expect that most worlds in the galaxy will fall into a few well-defined categories, each with its own characteristic properties. We use world type to describe these categories and help organize the process of world design. Another advantage of using world types is that they give the GM control over a setting. We could take a different approach, randomly selecting a world's primary first star and then placing worlds, then generating the properties of each world, but at the end getting an idea, only at the end getting an idea of what each world will be like. Many science fiction role-playing games take this approach, and a GURPS GM has the same option when using the advanced system in Chapter 5 of this book. However, if the GM has a desired result, this approach makes it difficult to guide the process toward that result. There's no guarantee, for instance, that a randomly generated star system will contain a pleasant Earth-like world if the GM wants one. It's much easier to specify the desired properties for the main world of the star system first, and then go through the rest of the process in such a way that every result is consistent with that starting point. World types are the easiest way to define this kind of design system, so this is why we're doing that. Overall type table, a 3d6. Roll overall world type table if you are on a hostile, barren, or garden world. Tweaking the world type table. By default, the default world type table given is appropriate for a moderately realistic space setting, one in which the pleasant garden worlds are uncommon but not vanishingly rare. In most star systems, the focus of human activity will be some uninhabitable but not active hostile world, an asteroid belt, a Mars desert planet, or the moon of some larger planet. Only in a few star systems will visitors tend to come to the more hostile environments, such as a standard greenhouse or large ammonia world. The GM can alter the distribution of the worlds to suit his own needs by writing his own overall type table or world type table. To increase the probability of a world type, give it a wider range of values, or move its range closer to the center of the table, using a bell curve. To make a world rarer, give it fewer table entries and push it toward the top or bottom of the table, or even remove it from the table entirely. We do have atmosphere types here. Atmospheres are defined by their pressure. Atmospheric pressure is measured in atmospheres, ATM, with 1 being equal to the average sea level air pressure on Earth. GURPS also classifies atmospheres into categories based on pressure as described in the following table. Atmospheric pressure table. Trace, very thin, thin, standard, dense, very dense, and super dense. Lynn says the ability to retain H2O is highly dependent on the exosphere temperature. I'm a geek, so I wrote a spreadsheet to give me the exact numbers. Oh, that sounds great. I remember playing the Buck Rogers CRPGs by TSR and SSI, basically AD&D in space, and it was all based on the solar system, and it was interesting how different each planet was colonized. Huh. So toxicity rules. Many different atmosphere types are toxic in the sense used on basic page 429. However, some poisonous atmospheres are much more dangerous than others. Any character exposed to a toxic atmosphere will need to make an HT roll on a periodic basis to avoid taking toxic damage. The differences between various toxic atmospheres affect how often these HT rolls must be made, what penalties are applied to HT rolls, and how much damage is taken when the HT roll has failed. The exact details will vary from atmosphere to atmosphere, but this book will use the terms mildly toxic, highly toxic, and lethally toxic as general categories. Mildly toxic. Exposure requires an HT roll no more often than once per hour. Well, that's still a lot of rolls. There's no penalty to the HT roll, and a failed roll inflicts only 1 point of toxic damage. Characters may risk brief exposure to a mildly toxic atmosphere without much danger of serious injury or death. You still should probably have a spacesuit, but you could operate for a little while in a mildly toxic environment. Highly toxic exposure requires an HT roll up to once per minute. Definitely bring your spacesuit. The HT roll will usually be at -2 to -6, and a failed roll inflicts 1 point of toxic damage. Characters may risk very brief exposures to high toxic atmosphere, but only in dire emergencies. Lethally toxic. Exposure inflicts 1d or more toxic damage every 15 seconds with no possibility of resistance. Characters exposed to such an atmosphere will die in a very short time. Stray says, I think Starfinder has a deck of cards you can make a random planet for exploration. It gives races and everything. Oh, card-based generation? I potentially like it. Determining atmosphere composition. Marginal atmospheres. What makes the air? When a planet first forms, it's likely to have an extensive atmosphere dominated by the most common substances in the universe, hydrogen and helium. Large worlds can hold on to this primordial atmosphere. Smaller ones lose it when their primary star ignites, entering the so-called T-Tauro stage, during which a massive stellar wind blasts the inner star system clean of gas and debris. Later, the last stages of planetary formation include a period of late heavy bombardment. This is an era in which young planets frequently collide with comets, asteroids, and even bodies as massive as moons or small planets. The smaller collisions, especially with comets or other objects containing plenty of ice, can leave volatiles behind to form an atmosphere and seas. The larger collisions may blast these early atmospheres away into space, possibly more than once. Eventually, the largest collisions come to a stop, and the young world can expect to keep any atmosphere it receives from comets and icy asteroids. In this stage, the primary source of atmosphere becomes the planet's own volcanism. Volatile substances locked into the world's icy or rocky body are released along with its internal heat. The result is a thin envelope of air, the world's first atmosphere. Of course, once the atmosphere is stable, chemical processes can alter its composition considerably. The most startling example of this is found on garden worlds, where photosynthetic life creates a substantial amount of oxygen in the air. Since oxygen normally combines with other chemicals very quickly, any world with lots of free oxygen in the atmosphere is far out of chemical equilibrium. The situation can only be maintained by the activity of plant life or some other continuous process. All of these processes are unpredictable. The atmosphere found on the given world depends strongly on its initial chemical composition, but the accidents of planetary evolution also play a strong role. Have I looked at stars without numbers? I have not. Stars without numbers? Oh, this is Stars Without Number, or Stars Without Number. So, Stars Without Number. I thought it was, so this is a science fiction role-playing game inspired by the old school Renaissance and the great fantasy science fiction games of the 70s and 80s. So somebody doing, oh, here it is. Stars Without Number. Oh, it has a revised edition here. Let's see. So somebody did like Starfinder, but for OSR. Null Inquisitor says it's dark. It's called the Deck of Infinite Worlds, and it's pretty good, although it's a bit Starfinder themed. We were a little bit unhappy with the, and in some cases a bit more than a little unhappy with the Pathfinder cards that we had. We looked at Pathfinder cards one day, and I wanted a lot more of them. I wanted a lot more out of them. We've looked at Starfinder before, but I think a deck of cards, the decks that they did create, I think could have been cool, but they needed to be pushed a bit further. So the Deck of Infinite Worlds might be good. Do come by the Discord server. Thank you, Stray. If you're here and you're just finding us, please do come by the Discord server. I remember Stars Without Number had a cover inspired by Star Frontiers. I haven't read it, though. It seems to be very old school. Oh, George says, being a firefighter, I too have an appreciation for hazardous atmospheres and an appreciation for protective gear. Hydrographic coverage. Determining hydrographic coverage. Each world type has its own association of hydrographic properties. When dice are used, the hydrographic coverage will be expressed as a multiple of 10% of the world's surface area. It would be reasonable to vary the result by up to 5% in either direction, with a minimum of 0% and a maximum of 100% surface coverage. These tiny worlds will have none of those types will have oceans. Their hydrographic coverage should always be 0%. But as an example here, since Haven is a standard garden world, it will have liquid water oceans. The GM rolls 1d4 plus 4 and gets a result of 10, suggesting that the hydrographic coverage is 100%. He doesn't want a world that's completely covered with water, but a world dominated by vast oceans seems appealing. He lowers the hydrographic coverage to 98% and makes a note of that Haven's landmass consists of a single Australia-sized continent and a scattering of island chains. Climate. We have a formula here. Temperature range gives a range of possible average surface temperatures in kelvins. Climate type is a descriptive name for the world's coverage of all surface climate. Temperature range F gives the associated range in degrees Fahrenheit. So temperature, world climate table, average surface temperature table. So here are different types of worlds. Here is our average surface range. It gives step 25 over here. Select a temperature within the range given, or roll 3D minus 3, multiply the result by the step value is for random generation. So you can select one within the range, or roll 3D minus 3 and then multiply the result by the step table and then add the minimum value from the range. The result is the average surface temperature in kelvins, a unit of absolute temperature. When using the dice, it would be reasonable to vary the final temperature by up to half of the step value in either direction. So once you come up with your surface temperature, then we can come up with our range. Temperature range F, get this right here, gives the associated value in degrees Fahrenheit. Gives the associated range in degrees Fahrenheit. To convert a temperature from kelvins to degrees Fahrenheit, use the following formula. So this is our conversion here. F is equal to 1.8 times K minus 460. Here, F is the temperature in degrees Fahrenheit and K is the temperature in Kelvin. Make note of both the average surface temperature in kelvins and optionally in degrees Fahrenheit and the corresponding climate type from the table. Temperature range in kelvins, temperature range in Fahrenheit, and this gives you frozen, very cold, cold, chilly, warm, tropical, hot, inferno. Determining black body temperature. Another parameter related to the world's climate is its black body temperature. This is the average surface temperature the world would have if it were an ideal black body, a perfect absorber and radiator of heat. Of course, real worlds are not ideal black bodies, so the black body temperature is usually different from the world's average surface temperature. So why do we need to do that one here? Here is to determine our black body correction for a world. Use the following. C equals A times 1 plus M times G. C is the black body correction. A is the world's absorption factor from the table. So wait, absorption factor, greenhouse factor. M is the world's atmospheric mass as generated in step 3, and G is the world's greenhouse factor from the table. Note that for a world with a greenhouse factor of 0, a world without significant atmosphere, the black body correction is equal to the absorption factor, C equals A. So, for instance, for Haven is a reasonably pleasant world if lacking in dry land. The GM decides that surface climate should also be pleasant and sets its average surface temperature to 295 kelvins, about 70 degrees Fahrenheit. Haven has normal climate type. Referring to its temperature factor table, the GM finds that Haven's black body correction is 0.84 times 1.1.2 times 0.16 equals 1. Haven's black body temperature is almost exactly equal to its average surface temperature at 295 kelvins. That's because it was mostly water. It was mostly covered in water. I'm not exactly sure why you need to generate all this stuff. I mean, this can be fun, can be fun, but on the other hand, the style of gaming that I'm trying to move to has kind of left this behind. Black body temperature, Lynn says, is probably the simplest to calculate. You just need to know the luminosity of the star and the distance from it. I calculate it directly for any world I'm detailing. Cool. How many worlds have you generated? Like, do you send your RPG players to a bunch of different worlds in your campaign setting? How many have you generated for them? Let's see, turning up the heat. The absorption factor and greenhouse factor for each world types are typical values rather than universal constants. It would be reasonable to vary each slightly to reflect changes from normal properties of the world's type. The absorption factor might vary by as much as 0.05, with a minimum of 1 and minimum of 0, maximum of 1, minimum of 0, and to indicate the surface is more or less reflective. A dark surface, such as dark stone, ice darkened by chemical processes, or dust in the upper atmosphere, would have a higher absorption factor. A bright surface, such as snow or polished ice, would have a low absorption factor. For example, Earth's current absorption factor is about 0.88, and this is taken as the typical value for a standard garden world with moderate hydrographic coverage. During the last ice age, the vast areas of land covered by ice and snow would have reduced the absorption factor by 0.86 or so, enough to lower the average surface temperature by several kelvins. Meanwhile, if the greenhouse factor for a world type is not 0, it might also vary by up to 0.05 in either direction to reflect local variations in atmospheric composition. To change the concentration of the greenhouse gases too small even to render a breathable atmosphere. A change in the concentration of greenhouse gases. A change in the concentration of greenhouse gases too small to even render a breathable atmosphere, marginal, could have dramatic effects on local climate. For example, Earth's current greenhouse factor is about 0.16, but during the Cretaceous era, 146 to 65 million years ago, it may have been as high as 0.2 due to the high levels of carbon dioxide in the atmosphere. This book also took a lot of research. In any case, variations in absorption factor and greenhouse factor are not significant to the world's design system, but the GM should feel to use them to reflect features of the local environment. Whoa, something we found out here was not significant? I guess that's why it's in this box and not in the main text. World density here. Oh, so we come up with surface gravity. Once the world's density has been fixed, it's possible to determine the diameter and surface gravity. Those two parameters are closely related. If you select the world's diameter, that determines its surface gravity, and vice versa. The following rules will permit the GM to select those two parameters in either order. So if you know that, if you want to select the world's diameter first, refer to the size constraints table right here for the world's size. Multiply the square root of B divided by K, where B is the world's black body temperature in kelvins, and K is the world's density in units of Earth's density. So, okay, so in order to generate our gravity, that's one of the reasons we need the black body temperature in kelvins. Make the appropriate minimum value, multiply the square root of B divided by K by the appropriate minimum value on the table. The result is the minimum possible diameter for the world expressed in multiples of Earth's distance, of Earth's diameter. Similarly, multiply square root of B divided by K by the appropriate maximum value from the table to get the maximum possible diameter of the world. Select any value within this range for the diameter. To select a diameter at random, roll 2D minus 2, multiply by 1/10 of the difference between the maximum and minimum diameter values, and add the result to the minimum value. Feel free to vary the final result by up to 5% of the difference, so long as the final value is within the range. To express any diameter in miles, multiply the value in Earth diameters by 7,930. Once the diameter is known, use the following formula to get the world's surface gravity. S equals K times D. Here, S is the world's surface gravity in G's, K is the world's density in units of Earth's density, and D is the world's diameter in Earth's diameter. That tells you the gravity. Or you could do this in reverse if you want to know the gravity and then determine, go back, whichever direction, whatever you were generating back from that. Now that the world's surface gravity is known, its surface atmospheric pressure can finally be determined. The various world types are likely to have wildly different atmospheric pressures. Refer to the following notes to determine the world's atmospheric pressure. So we've got pressure factors table. The atmospheric pressure is given by the following formula. P equals M times F times S. Here, P is the atmospheric pressure in atmospheres. M is the atmospheric mass as generated in step 3. F is the pressure factor from the appropriate world type from the table, and S is the world's surface gravity in G's. Make note of the result in the pressure category associated with the pressure from the atmospheric pressures table. So as an example, the GM has no preference for Haven's density and so rolls 3D on the world's density table, referring to the large iron core column. He rolls a 16 and records a density of 1.1, or about 16.1 G divided by CC, GCC. The GM then decides to set the planet's surface gravity first. This parameter must be between 0.03 and 0.065 times the square root of 295 times 1.1, or between 0.54 and 1.17. He decides to set the surface gravity to 1.15 Gs, making Haven a relatively high gravity world. The planet's diameter is then given by 1.15 divided by 1.1 for 1.05 Earth diameters. Finally, its mass is given as 1.27 Earth masses. Now that Haven's surface gravity is available, the GM can go back and determine the planet's surface atmospheric pressure. This is given by 1.15 times 1.2, or 1.38 atmospheres, which yields a dense atmosphere. The GM makes note of this under the world's atmospheric properties. Resources and habitability. Determining resources. Lynn says they've been to about a dozen or so talking about different planets in his campaign. I've generated hundreds with spreadsheets. Basically, a spreadsheet gives you as many worlds as you could possibly want at the touch of the recalc button. I think GURPS created a real Rube Goldberg system for mass, size, density, surface gravity. It's really a lot simpler than how they have been treated in it. If you scale everything relative to the values of Earth, G equals R times D, but D itself is a function of R, roughly the square root. Oh, thank you, Tomocrat. Tomocrat says, I placed a link to the free version of Stars Without Numbers. Or I think it's Stars Without Number. Stars Without Numbers in the Discord. Thank you. I'll think about that. So, well, I said I'm already seeing. I think this is too much. I mean, like there's a time in my gaming career when I really would have loved this, and I still do. But its usefulness, I think, is rather low, especially for setting up a whole bunch of stuff in advance. Because how is it like? What if you miss that? I suppose if you're writing something, trying to get these things right, you can use these formulas to make sure that you're in the ballpark and right on a bunch of different things. But for most gaming purposes, I can't really see this mattering that much. So we got a resource value table determining habitability and affinity. The habitability score for a given world is a summary of all the factors that make the world pleasant for humans to live on. Habitability runs from -2 to 8, with higher scores indicating a more pleasant environment. To determine the habitability score for the target world, refer to the following table and add up every modifier that applies. Make note of the final habitability score for the world. Here's breathable atmosphere, liquid water oceans, breathable atmosphere, depending on your climate type, depending on the density of the atmosphere, and so forth. And here we go. The affinity score for a given world is a summary of all of the factors that make the world attractive to human settlement. Affinity is a number between 0 and 10 and is closely related to the resource value modifier. To determine the affinity score for the target world, add the resource value modifier to the habitability score. Make note of that. For instance, the GM decides that Haven doesn't have any special resource abundance, or poverty. Its colonists have chosen to settle there because of its location, not because of its natural resources. He sets the planet's RVM to 0. Haven's habitability score is 7, so its affinity score is also 7. Habitability for aliens. The habitability rules assumes that human comfort is the primary yardstick by whether or not a planet is going to be attractive. An alien race that's evolved under different conditions may judge worlds differently. If the GM is designing worlds within the space claimed by an alien race, he should design his own habitability modifier table for that race. The following guidelines could be of assistance. The range for possible habitability scores should be the same as human colonized worlds, -2 to 8. The planet's atmosphere should usually be the factor with the greatest weight. For human colonized worlds, half of the maximum habitability of 8 depends on the quality of the atmosphere. Having enough air to support intelligent life is important, but the atmosphere whose composition is actively hostile to the world's inhabitants is likely to be imposing a penalty on habitability. Hydrographic coverage. Most forms of life will be dependent on liquid volatile. Water for human-like creatures, liquid ammonia and ammonia for ammonia-based life, and so on. For human colonized worlds, 25% of the maximum habitability depends on the hydrographic coverage. Land-living species will want plenty of coastlines and well-regulated inland regions, which will occur when hydrographic coverage is high, but not too high, since a world with nothing but a few small islands will not offer enough land area to support the large population. Amphibious or shore swimming species will be happy with lots of coastlines, but won't care about the inland space, so they can tolerate more land area. Deep ocean species will want lots of hydrographic coverage, and the more the better. Of course, in the world's oceans aren't even based on the same chemistry the colonists evolved for. That will be useless. And then climate as well. Social parameters. Oh, we hadn't even started. Yeah, you're right. That says, so far, the design process has designed the physical parameters of the world under construction. The next few steps determine the social parameters for each world, how many humans or whatever sapient species live there, the kind of government they live under, and how much trade they engage in, and so forth. Well, yeah. All right. Boy, and that wasn't even the advanced world building. That was a lot. Then there's advanced world building. So exactly what is it that, well, I guess we'll find that out maybe tomorrow or the next day. What exactly it is that we had to skip over in basic world building, because that still seemed like quite a bit. But yeah, social parameters. We haven't even talked about what aliens are living there yet. Lynn says, there's lots of good ideas here, but I think the crunchy bits could have been better written. I do like the idea of some cards. I might have to come up with the Pathfinder, Starfinder deck, World Builder deck, because I bet if you do have to, oh my God, we're crash landing on some kind of planet. What is the planet like? What actually is going to matter as far as the game? Going through all of this seems unnecessary. All right, I am going to in many ways, I think the Traveler system for world generation is superior, far less detailed though. That's where the GM's imagination comes in. Well, and especially if you're trying to tell some kind of story. Like, we're not like, are we really trying to simulate the development of some planet and all of its factors, or are we trying to tell a story here? It depends on your style of gaming. It depends on your style of gaming. Are you trying to simulate something, or the deck of many worlds? Stray says. I might put it in an Amazon shopping cart to get it eventually. But it depends on what you're trying to do. If you're trying to tell a story, yeah, it's probably important, especially if you're writing it, to maybe use some of these factors to make sure that the planet that you're creating does make sense. But the factors that are there for the adventure of the story is going to be more important. All right. I got things to do today. So everybody have a wonderful day. Be creative, be constructive, grind on. I'll see you tomorrow.